Good afternoon, all. Now, audible. Screen is visible.
Yes, ma'am.
Yes, ma'am.
Okay, thank you. Okay, so in yesterday's lecture, we have started the fourth chapter revision, whatever part we have covered earlier. So only one point is remaining, whatever we have covered in last few lectures. Okay, so I quickly go through it and we'll start a new point from today. Okay. So yesterday we were seeing what is meant by the CSMS CD. So as I told you, CSMS CD, it is nothing but it stands for carrier sense multiple access with collision detection. So these protocols are mainly used not only to detect the collision, but these are also used what will be done if the collision is occurred. So so for that is again decided or that can be decided by using these protocols. Okay, so CSMA series, these are such type of protocols. So here there is one diagram. So actually this diagram or you can see here that collision or CSMA CD, it is done in three stages. Okay. Okay, so first one is the contention, then transmission, and the idle. These are the three states where or with the help of which CSMA-CD is carried out. So first one is the just see here. It is a transmission period where the frame can be transmitted, or if we can say that it is a free time slot where frame is to be transmitted. And second one is the contention period. So contention period is or contention slots. These are the slots where collision can occur. So because we can consider that it is a free slot, and within this slot only the contention can collision can be occur. So contention period or the contention slots are called nothing but the collision slots that we can say. And idle is nothing but the channel is free and the frame can be transmitted. Okay, so there are some collision free protocols that we have seen in earlier lectures. So though collision doesn't occur in CSMA CD once the station has captured the channel, but they can occur during the contention period. So as I told you, this is the slot where contention can occur. So collision affect obviously the performance, and collision specifically occurs if the cable is too long or the distance is too high and frames are short. So these are some reasons where collisions can occur. So directly we'll go for these protocols with the help of which or where collision is avoided. Okay, so first one is the bitmap protocol and second one is the binary countdown protocol. These are the two major protocols which are used which are considered as a collision free protocol. Okay, so see here what is mean by the bitmap protocol. Okay, so as I already told you, contention slot or contention period is the slot where collision can occur. So these two protocols are mainly working for that only. Okay, means to avoid the collision during the contention slots only. Now you can see here, suppose there are 8 slots, 0 to 7. 8 contention slots are there. And out of these 8 slots, suppose some slots or some stations want to send the frame. Okay, some stations want to send the frame. So the station or the slot, those who want to send the frame, what they will do, they will just transfer one bit into its slot. Okay, one bit into its slot. So there are 8 slots are there. So 0, 1, 2, 3, and so on. So suppose slot number 1 want to send the frame, so it will transfer one bit into its slot. 3, it transfers one bit into its slot. 7, it transfers one bit into its slot. Once all the slots or all the contention periods are get over, How the frames are to be transmitted? So in a numerical order, they are being transmitted. Okay, so in numerical order, they are transmitted. So you can see here, first this frame is being transmitted from slot number 1, then slot number 3, then slot number 7. So numerically each frame will be transmitted. Now how the collision is avoided over here? So obviously everyone get a chance to transfer. Okay, so if they wish to transfer, they have to send one bit during its slot, but during this contention slots only. Once this slot is over, no one is allowed to send the frame. So obviously, no anyone is not enter will not interfere in any other's slot, and that is the reason that collision can be avoided over here. Okay, so you can see here in the second diagram, fifth slot number 1 and 5 they are sending. So 1 and 5. So obviously, how to send is decided, and that is the reason that no collision can be avoided over here by using the bitmap protocol. So this is the first collision free protocol, and second one is the binary countdown protocol. Okay, so there is a very small drawback we can say for the of the bitmap protocol, and the drawback is that we need to depend, or the protocol is working on only one bit. Okay, at a time only one bit it is working on, so it will be a quite lengthy process. So for that, binary countdown protocol is used. Okay, now how it works? So in case of the binary countdown protocol, addresses are used. Okay, in case of the binary countdown protocol, like, okay, so in case of the binary countdown protocol, it is working on the addresses. So the station, those who want to send the data, so what they will do, they will send their addresses first. Okay, likewise 001001001001 and 1011. Okay, so once they send an addresses, what is the next stage? So first bit of every address is being considered a first. Okay, so 0011, that will be the first bit. Now what will happen? They are just on this first bit, boolean or operation is performed. Okay, boolean operation is performed. Meanwhile, what happens is that, so this station considers that or the answer is 1. So at that time the station, yeah, here it is given 0010 and 0100, they sees that some other stations are having 1 in their addresses. Okay, so what they will do, they will skip by their own. Okay, so they will be out of range. Then next, remaining two will be in a race. So next bit is 0 and this 0, again boolean or operation is performed. Again third, here 00 are same, so both will be in against race. Then 0 and 1, these are the two, 0 and 1. So 1001, this station will look that some other station is having 1 in its address. So what it will do? It will out of the race. So only one station will be there for this current moment 1010. So this will be on the race, and this 1010 station will get an access for a channel. Okay. Once this 1010 completes its transmission, what it will, again the same procedure will be followed within these three remaining three, 0010 0100 1001, and the same procedure. So after that, maybe these two will again boycott, and only this channel will get an transmission chance. So likewise, each one will get a chance for a transmission of the frame, and obviously collision will be avoided. Okay, so this is nothing but the binary countdown protocol. See, whatever protocols we are seeing, what is the purpose of that protocol is that what is considered, why these are used. So the reason is what is the condition? There is only one channel and number of station want to access that channel for transmission of the frame. Okay, and all these protocols are used for that purpose only. Okay, what will be what or how to get an access for a channel if there are n number of users are there, and these are the all protocols that we have seen. Okay, so up to this, I think we have covered in last few lectures. So next point for this chapter is the limited contention protocol. Okay, so up to this point, whatever point protocols we have seen that are generally depending upon two basic strategies. First one is the contention methods, that is CSMA, means first check the status of a channel and then transmit, then collision can be occurred. So this is the first strategy protocols, and second strategy was collision free protocols, means where collision is avoided, that is binary countdown and bitmap protocol. So these protocols we have seen, but if we consider the performance of these protocols, then somehow we come to conclusion that these protocols are not of use if we increase the load. Okay, so we say that yes, binary countdown, bitmap protocol, these are working properly and collision will not occur over here. But these are working properly only if the nodes are limited. Okay, so if we increase the load or if we increase the number of stations for a same channel, then it may be possible that, or it is there that these protocols are not working properly. Okay, so we can use two performance measures are used for all these methods. First one is the delay at low load. Okay, delay at low load means what? If number of stations are very low, then how much time it will take to give a chance for every station for accessing the channel. That is nothing but the delay at low load. ओके, मीन्स व्हॉट, एक स्टेशन सॉरी एक चॅनेल आहे आणि त्याला फक्त 3च नोट्स ऍक्सेस आहेत. ठीक आहे, आणि त्या 3 नोट्स साठी प्रत्येकाला चान्स मिळायला किती वेळ लागतोय? Depending upon that, performance will be measured. First one. And second one is the channel efficiency at high load. Suppose it is working properly, but if we increase the load, if we increase the number of stations, then how effectively channel is transmitting without collision, right? So that is nothing but the channel efficiency. Okay, so these are the two performance measures which can be used to measure the performance of your protocol, whatever we have seen. So we have seen some of the protocols like Aloha and slotted Aloha, so binary countdown, bitmap protocol, all these protocols, so right? But as we know that Aloha, slotted Aloha, or these two all are working properly at its low load. But if we increase the load, then contention is not useful. Okay, because these are not working properly. So it is required that the properties of contention and collision free protocol should be combined together to get a better result. Means CSMA or Aloha, slotted Aloha, binary countdown, bitmap protocol, whatever we have seen. So everyone has its own advantages as well as the drawbacks. Correct? So these all protocols should be combined together to get a better result. Okay, so such protocols are called as a limited contention protocol. ठीक है. So how this protocol works, are you understand what is the purpose of the limited contention protocol? Because the protocols which are used or which we have seen earlier, so all that protocols are used or working properly at the low load, or these are the collision free protocols, then they are having the minimum collision or no collision if the load is low. So if the stations are increased or load is high, in that case, maybe these protocols will not work properly. And to improve the performance, the properties of all these protocols are combined together, and such protocols are called as a limited contention protocols. Okay? Now, let's see the diagram over here, which will show you why the limited or how what is the use of the limited contention protocols. Okay, so you can see here what is this probability of success of getting uh, access for a channel. So that is shown over here, and these are the number of ready stations. Okay, number of ready stations. Okay, these are the number of stations, and this is the probability of success of getting the channel for transmission of the frame. So you can see here it is the high probability point where we can get an access for a channel when the number of stations are low. You can see here number of stations are low. So as the stations are goes on increasing, the probability of getting access for a channel is goes on decreasing. Okay, so it is clear that if the probability, if we want to increase the probability of success, then the channel should be minimum, or the station should be minimum, right? So that is shown over here. But how the station should get minimized? Obviously, one channel is there, stations are already there. Suppose 20 stations are there, all these stations are there. How to minimize them? Everyone want to access this channel. Okay, we cannot boycott anyone. So how to minimize this competition of getting access is done by using limited contention protocol. Now how it works, just see here. So what they suppose there are 8 stations are available. 1, 2, 3, 4, 5, 6, 7, 8. 8 stations are there. They all are trying to access only one channel. So in case of the limited contention protocol, all these stations are grouped randomly. Okay, so how they are working? They are just grouped randomly. Means there is no fixed criteria that in one group how many stations will be there. Okay, so they are grouped randomly. Now after grouping, how it is working after grouping, every group will get a chance of a channel. Okay, acquiring the channel. So instead of having the competition of remaining all 8, the competition will be within 3 only. Okay, similarly within 2 only, and within 3 only. Now what is done over here, we have just minimized the number of stations. So obviously if number of stations are minimum, means the chances of getting the access for a channel is obviously high as per this diagram. Correct? So in this way the limited contention protocol works to have the channel access. I hope it is very clear. Okay, what is this 0, 1, 2? These are the groups, and these are the stations. Whatever stations are there, they are randomly grouped together. Okay, and once the groups are done, every group will get an access for a or chance to access a channel. So instead of having competition for all other stations, the competition will be within the limited stations only. Okay, so due to this it will increase the probability of getting access for the channel. Okay, so once this group number 0 completes, then group number 1 will get a chance, then group number 2 will get a chance, and so on. Okay, so these are the it is called as a limited contention protocol. ठीक है, समझते any doubt? Yes, any doubt? Yes, any doubt? No doubt. Okay, so then we will see the next point. I think there is no doubt from your side. Okay, adaptive tree work protocol. This is also one type of strategy we can say, which is used or for the limited contention protocol. So how they again here groups are made. Again here groups are made. So for example, just say 0, 1, 2, 3, 4, 5, 6. These are the groups and these are the stations A to EH. Now how the groups are made? Just see for example A to H stations are there and they all are working for or they all want to access only one channel. So for example first group is made for this A, B, C, D, and the second group will be made for EF, GH. Okay, so these will be the two groups initially. Now suppose out of these A, B, C, D, suppose A get an access for a channel initially, so that it will transmit. Okay, but suppose at a time A and C both want to or both get an access for a channel, so maybe collision will occur. In such case, again this group is subdivided. Okay, in such a way that AB will be in one group, that is group number 3, and CD will be in one group, that is group number 4. Similarly, here also, initially first group is EFGH. So suppose G get an access for a channel, so it will transmit. But if collision occurs, then again the next group will be formed as like EF in group number 5 and GH in a group number 6. Okay, so this is called as an adaptive tree work protocol, which is also called as a binary tree work protocol. Okay, because it is working on a binary tree strategy. That is nothing but exactly two halves or two leaves should be there for every node. Okay, so this is the adaptive tree work protocol. Then next is the wavelength division multiple access protocol. Wavelength division multiple access protocol. Okay, so in this protocol, different approaches are used to allocate a channel, like divide the channel into sub-channels by using FDM and TDM or both that we have already seen. Frequency division multiplexing, time division multiplexing. Okay, so one such protocol which allows transmission at the same time using dividing available wavelength into equal spectrum is a WDMA, that is wavelength division multiple access. Whatever strategies we have seen earlier, that is FDM and TDM, for them there was a problem that if the stations increased after allocating, then it is not working properly. So this is the protocol which is used for multiple access. Okay, I hope you are remembering whatever we have seen yesterday regarding this FDM and TDM. आठवते का? Okay, what is the problem in FDM and TDM? See, unless and until you give me the answer, I'm not going forward. Okay, I'll point any one. You have to give the answer. Otherwise, I'll mark a absentee. Because only I'm talking, there is no response from your side. Yes, Pooja. Pooja Patil, roll number 21. Yes. Yeah, what is the problem in FDM or how they are working, FDM and TDM? Can you tell? Yes, how they are working? Yes, Sanika, roll number 27.
Yes, ma'am.
How FDM and TDM is working? Hmm? Yes, Saloni. Yes, how they are working? Tell me. Any one of you. Hmm? What are you doing in lecture then? Just listening. Not listening also. Hmm? फक्त लॉग इन करायचं आणि नंतर we don't know what is going on in lecture and what is when the lecture is completed, that also we don't know. Hmm? Yes, tell me. Yes, Pranav Tongre. Are you there? Pranav?
Yes, ma'am.
Okay. So what we have seen how the FDM and TDM is working. Yesterday's lecture only we have seen it. Hmm? Don't know. Great. Hmm. Yes, anyone can answer.
FDM allows transmission of different data slot using different
Mm,
frequencies.
mm, okay. Good. At least she tried. I don't know answer is correct, but at least she tried. Others. How the FDM is working? Yeah, speak up. Vishal, Aniket. Hmm? It is of no use if this is the situation only faculty is teaching and you are not attending anything. It is of no use. In between, you are leaving the lectures. Hmm. If we don't know how the FDM and TDM is working, how will we understood what is meant by the wavelength division multiple access? Huh? In yesterday's lecture only we have seen this. How to do how this FDM and TDM is working. Still, if we are not able to tell, then what is the use? Hmm? So FDM and TDM, these are the static, what we can say, channel allocation problem. In that point, we have seen it. How the FDM is working, how the TDM is working. Okay, so suppose there are four stations are there, and whatever wavelength is available, that total wavelength is divided equally divided among these four stations. That is called as an FDM, that is frequency division multiplexing. And TDM is what? For all the four stations, some time slot is allocated, and within that time slot, every station is allowed to transmit the frame. So that is nothing but the TDM. But what is the problem over here? Instead of four stations, suppose five stations are there. Okay, so this division of wavelength will not be useful for the fifth station because it is divided for the or it is allocated for four stations only. So remaining one station will not be in use. Correct. Similarly, over here also. So these are the problems where multiple access is not allowed or it is not useful. So for that purpose, wavelength division multiple access is used. Okay, so how it works? So this protocol allows transmission at the same time using dividing available wavelength into equal spectrum. It is called as the WDMA. So this is the diagram for wavelength division multiple access protocol. So how it is works, so you can see here, these are the stations A, B, C, D. Okay, four stations are there, and for every station there are two channels. Okay, for every station there are two channels. First one is used to provide or which is used as a control channel. So you can see here, so every channels sorry, every station's narrow section is used for controlling the channel. Narrow section means जो छोटा सेक्शन आहे तो कशासाठी यूज केला जातो तर कंट्रोल साठी यूज केला जातो कंट्रोल चॅनल साठी and the broad section is used as a data channel. So you can see here, this is the broad section where which is used for a which is used as a data channel for every station. This is for a control channel, this is a data channel, control channel, data channel, control data. So these are the These are the basic information of this diagram. Now how it works. Okay, suppose uh, this is the control channel. Okay, A is control channel and this is the data channel. So how many control channels and how many data channels will be there, we will see. Suppose here m slots are there. Yeah, I forgot. So every control channel, it is divided into m equal time slots. So you can see here प्रत्येक स्टेशनचा कंट्रोल चॅनेल हा m स्लॉट्स मध्ये डिवाइड केलेला असतो, टायमिंग स्लॉट मध्ये डिवाइड केलेला असतो. अँड एव्हरी स्टेशन इज हॅव्हिंग n प्लस 1 डेटा स्लॉट्स. Okay, n plus 1 data slot. What is this n plus 1? N is used for to save the data, and 1 is the used for a status, or it is used for a status. What is the status? It just checks whether it can, or the station, or what is the status of the other station, which slot of the B station is empty, which is occupied. So for that purpose this status is used. So for every station n plus 1 data slots are available and m time slots are available. Now in general, how they communicate with each other. For example, station A want to send the data to the B, or A want to transmit the data to B. Then how it will communicate? So A will communicate to the B's control channel. What A will do? A will communicate to the B's control channel that yes, I want to send a frame, or I want to communicate with the B. So if B is free, okay, P is not accessing any other data, or any other transmission is not along with the P, then B will send a message or reply to the A's control channel. Okay, that you can send the frame, and then A can send the frame. Okay, so this is the in general communication which is happening between the every station if they want to communicate with the each other. In detail we will see. So just remember that every station has two channels. One is used as a control channel and second is used for a data channel. Control channel is divided into equal time slots, and this data channel is divided into n plus 1 slots. So n is the number where data can be stored, and s is used as a status to know which frame or which station is busy or free. ठीक है. So these are the working of the general communication between the A and B. Now we will see. So each this we have seen control channel, and the second one is the output channel or the data channel which is called. So each station has two transmitter and two receivers. प्रत्येक स्टेशनला काय असतात, दोन ट्रान्समीटर आणि दोन रिसिव्हर असतात. फॉर व्हॉट पर्पज? सी हियर. फिक्स्ड कुठले कुठले असतात? फिक्स्ड वेवलेंथ रिसिव्हर फॉर इट्स ओन कंट्रोल चॅनेल. फर्स्ट वन इज व्हॉट? फिक्स्ड वेवलेंथ रिसिव्हर, अँड सेकंड इज द फिक्स्ड वेवलेंथ ट्रान्समीटर. रिसिव्हर कशासाठी असतो? कंट्रोल चॅनेलसाठी, अँड ट्रान्समीटर टू गिव्ह द आउटपुट डेटा. So that is these are the two receiver and the transmitter. And second is what? Tunable transmitter for sending on other stations control channel. You can see here why it is called as a fixed and tunable. You can see here these slots are fixed, data slots are fixed, but here it is not fixed. Dot 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 it is given. Okay, so this transmitter and this receiver, tunable transmitter and receiver, these are used for this purpose, and fixed is used for data control. So tunable transmitter for sending on other stations control channel, and tunable receiver for selecting the data transmitter to listen to. So these are the two transmitter and receivers are used by every station. Now this protocol, that is wavelength division multiple access protocol, this uses or it handles three types of the classes or three types of the traffic, we can say. or these are the three ways how the communication is happening between the every station, or broadly categorize, we can categorize this type of the communication. First one is the constant data rate connection oriented traffic, variable data rate connection oriented traffic, and datagram traffic. So these are the three services or the classes which are supported by the WDMA. We'll see one by one. Variable data rate connection oriented traffic. Okay, so how it works, see here. So connection oriented, so obviously connection is established to exchange the control information but not for the data. So A आणि B ला कम्युनिकेट करायचंय, तर त्याच्यात काय होतं, फर्स्ट कनेक्शन एस्टॅब्लिश केलं जातं ह्या दोघांच्या मध्ये. कोणामध्ये कनेक्शन केलं जातं, टू एक्सचेंज कंट्रोल इन्फॉर्मेशन बट नॉट फॉर द डेटा. ओके, फर्स्ट कनेक्शन कोणासोबत एस्टॅब्लिश केलं जातं, कंट्रोल चॅनल सोबत, नॉट डायरेक्टली विथ द डेटा चॅनल. Okay, so how the connection is established? For example, there is a frame for you in slot 3. So what A will send to B, there is a frame for you in slot 3 to the B. Okay, now suppose B is already busy and suppose collision is occurred. Collision is established in the connection. Okay, so again the next process, the next, अरे बाळ माझं लेक्चर चालू आहे ना. Okay, so if suppose collision is established in the connection and connection is there, and suppose the connection is not established, so again A will again try to connect with the B. Okay, so now suppose this is the first problem, if the connection is not occurred. But suppose if the connection is occurred and at the same time two stations are establishing the connection with the B. A is also establishing the connection with the B and C is also establishing the connection with the B. Okay, for the same slot. Okay, now in such case what B will do, B will choose any one station and send the frame and discard the remaining. Okay, what B will do, B will choose any one of them by tuning itself to one of them and discard the remaining. Okay, A आणि B सॉरी A आणि C दोघांनी पण कनेक्शन एस्टॅब्लिश केलंय आणि दोघांना पण ह्याच्यासोबत ट्रान्समिट करायचा डेटा. ओके, मग B काय करणार, आयदर A और C दोघांपैकी कोणाला पण एकाला सिलेक्ट करेल आणि रिमेनिंग स्टेशनला डिस्कार्ड करेल and communication will be carried out with the C. Okay, so this is the first type of the service or class that is carried out. Then second is the constant data rate connection oriented traffic. Okay, constant data rate connection oriented traffic. So again connection is established in data slot also. आधीच्या ह्याच्यामध्ये कशात होतं कनेक्शन, फक्त control channel मध्ये होतं. Now in second type of classes the connection is established during the data slot also. Okay, directly to send a data. Now how the communication is happening, see here, when A asks for a connection it also says something like, it is all right if I send you frame in every occurrence of a slot 3. Okay, now I'll show you. Suppose B want to send a frame to C. Okay, B want to send a frame to C. So what it will do, it will add a connection to the control channel as well as to the data channel. Now in this case or in this second type of the service, what it will do, instead of sending the data, it will ask the channel or it will ask the station that your third slot is free, right? Your third slot is free. Can I send the message or can I send the frame in occurrence of every third slot? Yes, इथं पण मी सेंड करू का, याच्यानंतर नेक्स्ट फ्रेम जेव्हा येईल त्याच्या पण थर्ड स्लॉट मध्ये मी माझी फ्रेम सेंड करू का, इथं असं ज्या ज्या वेळेस येतील आणि त्याच्या प्रत्येक थर्ड ऑकरन्सला काय होणार डेटा सेंड होईल. So likewise the request has been sent. So if suppose C is free, what it will do, it will allow, so obviously this slot will be allocated every time for the B only. Okay, so this is called as an constant data rate connection oriented. Constant, why it is called constant, I hope it is clear. Constantly only one slot is allocated for every frame transmission. Clear? Yes or no? समझ why it is called as a constant data rate? Okay, I hope it is clear. If you have any doubt, you can ask in between also. Okay, and the third type of the service is the datagram traffic. Okay, now how it works. So instead of writing connection request message into control slot, it writes the data for you in a slot 3. No connection is established even in the control slot. If B is free during that slot, it accepts the free. Okay, so instead of establishing the connection or waiting for a connection, what it will do, it will just transmit the data directly to the data slot. कंट्रोल चॅनेलला तो कम्युनिकेट करत नाही, डायरेक्टली डेटा चॅनेलला डेटा सेंड केला जातो. So that is nothing but the datagram traffic. So obviously if it is free, then your frame will be, or it will accept and transmit the frame, otherwise discard. ठीक है. So these are the three services which are used in a wavelength division multiple access protocol. Anybody is having any doubt? Yes, any doubt? No doubt. Okay. Okay, let's move to the next point. That is nothing but the wireless LAN protocols. Okay, wireless LAN protocols. So as the number of mobile computing and communication devices are growing day by day, so it is the demand to connect them to the outside world. Okay, so we need to connect them to the outside world. So if you remember that when the first means in the earlier computer era, so the computers are not that much compatible or that much not mobile mobility is there in a computers, that so that they can be connected with the outside world as like now. So even our phones are also getting connected in the outside world, but not the computers. But as the era is goes on, or the modems are there, then with the help of these modems, such things are becoming easier. But if we acquire or if we want to use the true mobility or the highest mobility, computers need to use the radio signals for the communication. Means there should not be any restriction, any barrier to have a communication during the mobility. Mobility म्हणजे काय, I think माहित आहे. What is mean by the mobility? Yes, mobility means what? Hmm? What is mobility? Mobility means what? you are using the phones, if you are using the wireless devices, and if you don't know the mobility, then don't use anything. Hmm? What is the mobility? Hmm. What is mean by mobility? Hmm? What is mean by mobility?
ability to
Hmm.
move freely.
Ability to move freely. Okay. Means what? Yes. Means what? abiliटी टू मूव फ्रीली म्हणजे काय? चार्जर कनेक्ट असेल मोबाईलला तर तुम्ही फोनवरती बोलत बोलत बाहेर जाऊ शकता का? नाही. राईट. सिमिलरली कम्प्युटर, आता लॅपटॉप आपण कुठेही कॅरी करू शकतो, तसं कम्प्युटर करू शकतो का? नाही. सो द वर्जन्स as they are goes on improving, the mobility is also improving in case of using the devices I'm saying. Now in case of the network, ओके, सपोज दोन सिस्टम्स मी कनेक्ट केलेले आहेत, त्याला मी लॅन केबल यूज केलेली आहे. ओके, दे विल गिव्ह मी सम फ्रिक्वेन्सी बँडविड्थ और with the help of which I can access the internet. Okay, or I can share the resources. Instead of that, suppose I have used some wireless modems or wireless things to get connectivity between the two devices. Okay, so it will give me some range, then I will access it and all. So if we want 100% mobility in case of the computers, then they should use a radio signals for the communication, which will give you the high frequency bandwidth. Okay, so in wireless LAN protocol, we are going to see some of the issues or some of the protocols which can be used to get an high frequency band, or how it gets an high frequency bandwidth, that we are going to discuss over here. Okay, so a system that communicates by radio can be considered as a wireless LAN. Okay, now what is this wireless LAN and all? Quickly I'll tell you. So unlike the cellular system in phone, each room or LAN has only one channel, the entire available bandwidth, or covering the entire available bandwidth and covering all station in its set. ओके, मीन्स व्हॉट, एक सपोज लॅब आहे, त्या लॅबमध्ये आपण लॅन कनेक्ट करून एक 20 मशीन जोडलेले आहेत, तर ते काय, तर जे काय त्या लॅबची कपॅसिटी आहे ती सगळी कशात असणार आहे, त्या 20 मशीनला ती बँडविड्थ डिवाइड झालेली असणार आहे. ओके, मीन्स दॅट इज लिमिटेड टू that particular lab only. Now it is important to know that in wireless LAN, not all stations may be within the range of one another, which leads to variety of the complications. Okay, it means that when we are using the wireless LAN, the stations which are close to the modems, or which are in high range of the modems, that are having the high bandwidth, and remaining will not have that much range of the bandwidth. Okay, so this is the issue first. Also, for indoor wireless LANs, the presence of the walls between the stations can have major impact on the effective range of the each station. ओके, तर वायरलेस लॅन यूज करत असो आपण एखाद्या रूम मध्ये, सो वॉल्स or the what we can say curtains also, or the immunity in the environment, so anything can hamper the impact of this range. Okay, effective range of the each station. Okay, now then how this bandwidth can be used or how this bandwidth can be maximized. Okay, so one is what can we use the CSMA, means before transmission can we check the status that yes there is no barrier within the environment and here I can get a higher range frequency, so I can send the frame. So it is possible. So the answer is obviously no. Why? These are the two problems in using CSM. So what is these problems? So see here. First is what here these two problems are given. That first one is what hidden station problem and second one is the exposed station problem. If we use the CSMA in case of the wireless LAN that we are discussing over here. Now suppose there are four stations available A, B, C and D. Four stations are there. Okay. Now in case of the wireless LAN, it is necessary that we to have a high bandwidth, obviously it is required that that station should be near to the other station or the modem. जो कोण रेंज ट्रान्समिट करतोय किंवा एखादा मोडेम आहे त्याच्या जवळचे जेवढे स्टेशन्स असणार आहेत त्याला हाय रेंज असणार आहे. सो कीप इट इन माइंड. सो ए बी सी डी दीज आर द फोर स्टेशन. नाउ सपोज A is transmitting the data. Okay, A is transmitting the data to the B. Now in this case A and B are close to each other, right? A is transmitting the data to B. A and B both are close to each other. Now suppose C also wants to transmit the data to the B. C ला पण काय करायचं B ला data send करायचं. Now in that case suppose CSMA is used. In this case suppose CSMA is used. Now what is the purpose of the CSMA? What it does, it checks the medium only, right? Now medium is what channel फक्त तो चेक करणार. आता इथं काय ट्रान्समिट होते का? No, it is totally free, right? So C will come to know that I can send the frame, so C will start the sending the frame. Okay, so unless and until the frame reaches to the B, C is not aware about the A, as A is too long than the C. Okay, means A is not in a range of a C. Okay, and due to this C is or collision can occur at B station, because A is also transmitting, C is also transmitting, so obviously collision will occur. Okay, so such problem is called as an hidden station problem. Okay, where the channel where the station is not able to recognize the potential of other channel which is too far from it. ठीक आहे. सी ए पासून सी खूप लांब असल्यामुळे सी ला काय कळत नाहीये की ए ट्रान्समिट करते. सो सच प्रॉब्लेम इज कॉल्ड एज अ हिडन स्टेशन प्रॉब्लेम. फर्स्ट वन. नाउ सेकंड सिनेरियो. Again there are four stations. Now suppose B is sending. Okay, suppose B is sending. Now in such case obviously B is sending the data to the A. Okay, again suppose CSMA is used, right? Suppose CSMA is used and somehow C when the frame reaches to the B, C will conclude that B is busy. Sorry, when C checks for a station, B checks for transmission of the frame. So at that time, C will come to know that B is busy with the some other station, because C is in a range of a B. करेक्ट. सी बीच्या रेंज मध्ये असणार आहे, जवळ आहे, त्यामुळे त्याला कळेल की बी दुसऱ्या कोणत्या तरी स्टेशनच्या ट्रान्समिशन मध्ये बिझी आहे. सो इट विल नॉट सेंड अ फ्रेम टू द बी, बट सायमल्टेनियसली सी ऑल्सो कन्क्लूड दॅट डी विल ऑल्सो बिझी विथ सम अदर स्टेशन, ऍज बी इज ऑल्सो बिझी. बी बिझी आहे म्हणजे दुसरा नेबर जो आहे तो पण बिझी असेल. सो सी विल नॉट कम्युनिकेट विथ द डी ऑल्सो. Okay, so such problem is called as an exposed station problem, the second one. Okay, when B is transmitting to the A, so at that time, suppose C wants to communicate to the B, but as C is in a range of a B, C concludes that B is transmitting to the A, but similarly, it also concludes that my other neighbor D will also be busy with some other transmission, so it will not send to neither D, neither B, and this is called as an exposed station problem. Okay, in case of the wireless LAN, if CSMA is used, so these two problems can get arise. Okay, now how to overcome, then what to be done in the wireless LAN protocols to avoid the collision and all. So two protocols are specially designed for the wireless LAN. Okay, so these are called as a MACA and MACAW. So that is nothing but a multiple access with collision avoidance. Okay, these are the two protocols which are specially used for the wireless LAN. Okay, now how these two protocols are working, so these are depending upon each other, so only some small changes are made in the MACAW, otherwise remaining things are same as a multiple access protocol. Now see, the basic idea is that for a sender to encourage the receiver into outputting a short message so that station nearby can detect a transmission and avoid the transmission for duration of the transmission of the frame. Okay, so this is the working of the protocol. I know nothing understood, so see the diagram. Now suppose how these are working. This is the working of MACA. Okay, so first protocol, multiple access collision avoidance, how they are working. Now suppose this is station A and this is station B. Okay. Now suppose station A wants to transmit the data to the B or transmit the frame to the B. So what it will do, it will transmit the message, one small message which is called as a request to send message, that is RTS, to B as well as A. Sorry, to B as well as other neighbor also, which is in the range of the A. Okay, so you can see here RTS and RTS. This station is in the range of this station A. Okay, now so obviously this station or will understood that A want to communicate with the B, so only B will respond to the A. Okay, so it will send a message that CTS, that is clear to send. Now when B is responding, it will send this clear to send message to A as well as the other neighbor within the range of the B also. So you can see here CTS is sent to A as well as this one here also. Okay, now obviously with this they will come to know that so these stations are busy with the other conversation or other transmission. So once the station A gets an clear to send message, it will send a frame, this one. Okay, and once the station B gets an frame, it again sends an acknowledgement. So here acknowledgement will be sent to A as well as to the B. Right, so now suppose acknowledgement is sent to A means it's a communication with the sampler. A has completed the communication. Now suppose next this station C wants to send a message to the B. So obviously once it get an acknowledgement, so it will come to conclusion that B's communication with some other station is over, because acknowledgement meaning क्या है कि I got a frame or I got a data. Correct. So it is the concluded that B has completed the transmission. with some other station. Which station don't know. So here, if C want to communicate, it can send a RTS message to B here. So obviously simultaneous sending of the frame is avoided. Okay, so this is called as an multiple access with collision avoidance protocol. समजलं? Yes, समजलं? Any doubt? Any doubt? No. Okay. So this is again some diagram for the same protocol MSCA and MSCAW. Sorry, MSCA protocol. So you can see here A is sending data to the B. So A will be in a range of the B, whatever I have explained over here. So that is shown over here only. Okay, by the other diagrams. Okay, so though they are sending the or they are avoiding the collision, it may possible that if the two stations try to send RTUs at the same time, then collision can occur. So the next protocol is designed, that is MACAW, that is nothing but the wireless protocol. MACA for wireless, multiple access with collision avoidance for wireless. So how it works? So as I told you here only, this acknowledgement is get added in case of the wireless or the second protocol. This MACAW. त्याच्यामध्ये काय केलेलं आहे की फक्त acknowledgement is get added. So up to this we can say it is the working of the MACA protocol, and one more change is done, that once we get an data or the frame, it should send an acknowledgement to the neighbor stations. So that is the working of the second protocol, that is MACAW. So you can see here, without acknowledgement, the data link layer frame lost were not retransmitted. So only one change made in MACA working is that it introduces an acknowledgement frame after each successful transmission of the data frame. So only one change is made that I already explained. So any doubt in these two protocols? Yes? Any doubt? See, so many times I'm asking because it is important part, but still you are not replying. Anyone is not replying. Hmm? Yes. Anybody is having any doubt? No doubt. Okay, fine. So let's go to the next part. Okay, so next part, it is very interesting. So Ethernet, directly no question is asked, but you should know what is mean by the Ethernet, which cables are used, how they look, what is their configuration and all. So it is very interesting. So please see what is mean by the Ethernet and cable type we are going to see. So Ethernet is a standard communication protocol embedded in the software and hardware devices. Okay. Ethernet is, before that, I just want to tell you that these names are fixed. Okay. So these names are defined by IEEE standards. Okay. IEEE standards. They define or they gives the names to each and every term which is used, which we are using. Okay, so Ethernet means what, then MACA means what. So all these terms are defined by the IEEE. What is this, how they are working? So we have a next chapter in that we will see in detail about this IEEE standards. Okay, so Ethernet is a standard communication protocol embedded in a software and hardware devices. Okay, it is used. So it is used for building local area network. LAN connect करायसाठी Ethernet use केलं जातं. So the LAN is a computer network that interconnects a group of computers and shares the information through cables or the wires. Ethernet network technology mainly works with the fiber optic cables. Okay, so wired for Ethernet connection, mostly fiber optic cables are used, which connects devices within the distance of a 10 kilometer and which supports 10 Mbps. Okay, so a computer now, how actually these are working on which places. So see here, so the computer network interface card, that is NIC card, is installed in each computer. Okay, and is assigned to unique address. The network कसं वर्कआउट होतं सी. Okay, so NIC card is installed in each computer and it assigns a unique address. So an Ethernet cable runs from each NIC to the central switch or hub. Okay, so I show you the diagram. Just see what is this. So Ethernet networking creates a communication system which allows sharing of the data resources, including printer, fax machines. Okay, so this is the Ethernet. Now see here. So what is how the LAN is working? See here. So every computer is installed this NIC card. Correct. And Ethernet cables runs from this NIC card to the central switch or the hub. So you can see here computer 1, 3 and 2. These are the different computers and they are connected to the one switch or the hub. Okay. So this is called as an Ethernet. Okay. So every computer will have a one card and through that this uh, what you can say this LAN network or Ethernet is working. Now I told you that some cables are used. Okay, wired cables are used, but it may possible that Ethernet can be wireless also. Okay, wired means direct connection is made between the computer and the switch or the hub, but it can be a wireless Ethernet also. So rather than using directly cable to connect the computers, wireless NICs are used radio waves for two-way communication with a wireless switch or hub. So you can see here, wireless switch or hub will be there, and these are not cables. Huh? These are not cables; they are just connected. Means shows the connection. Okay, so this instead of using directly cables, they are connected by using the wireless Ethernet or wireless switch or the wireless hubs. So it consists of Ethernet ports, wireless NIC switches, and the hubs. So you can see here. So Ethernet can be wired as well as the wireless. Means we can create a network by using wires as well as the wireless network. Now, for this creation, different types of the cables are used. Okay, and these cables are this in this chapter we are going to see these four cables. There are some other cables are also there in next chapters. I'll show you. So 10 base 5, 10 base 2, 10 base T, and 10 base F. These are the four cables which are mostly used for Ethernet LAN. Okay, and 10 base 5 it is called as a thick coaxial cable. 10 base 2 it is called as a thin coaxial cable. T twisted pair, F fiber optic. Okay, now this is also asked for MCQ. If you go through the question papers, these are asked for MCQ. 10 base 5 is dash dash type of cable. Likewise, questions are asked. So remember, 5 means thick coaxial, 10 base 2 thin coaxial, then T means twisted pair, F means fiber optic. Okay, now there is a meaning for this 10 base 5, 10 base 2. 10 base likewise. What is this? Is nothing but 10 base 5. For example, 10 base 5, it means that it operates at 10 mbps. It operates at 10 mbps. It uses a baseband signal, and it can support segments up to 500 meters. Okay, what is the meaning of this? 10 means what? 10 mbps. Okay, it works at a 10 mbps. Base mean it supports or it uses baseband signaling, and 5 means it supports segments or the range up to 500 meters. That is the meaning of 10 base 5. So 10 base 2 means it will support the range or the segments up to 200 meters. Okay, T means it is specially used for twisted pair. No range here and here also. 10 base is same 10 mbps and baseband signaling. Okay, so see one by one. We will see one by one every cable. So first one is the 10 base 5. So it is called as also called as a thin ethernet. So it is very cheap wire. We can see, you just see the diagram, and it is easy to install. Okay, it is very cheap and easy to install, but there is a restriction that it can run only for some few meters, or we can say 185 is given, 185 meter per segment, and it can handle only 30 machines maximum. Okay, for by using this type of cables. Sorry, it is 10 base 2. I'm telling 10 base 5 is a thick ethernet, and it is, yeah, it is sorry, 10 base 5, it is a thick ethernet, and it is the most or it is the first wire which is invented, and it is a original cable or original ethernet cable, we can say. Okay, and maximum 100 nodes or 100 segments it can handle, and it the length there or the meters, it is already told that 500 meters, up to 500 meters it can be used. And the next one is the 10 base 2. So it is called as a thin ethernet, which is very cheap and easy to install. So and it also bends easily, and but restriction is what? It is used or it can be used for 185 meters, up to 185 meters only, and it can handle only 30 machines. So there is a restriction. So this is the 10 base 2 cable or the 10 base 2 ethernet cable. Then next is the 10 base T, which is also called as a twisted pair cable. You might have seen. So most of the company टेलिफोन कंपनीज और आधीचे जे हे होते आपले फोन्स होते, you might have seen or not, I don't know. So these are using, or these are connected by using such type of the cables. Okay, so these are called as a 10 base T. Also in our labs also, whenever we will meet, we will see this type of the cables. I'll show you, they are there. So this is the 10 base T cable, and last one is the 10 base F. So that is nothing but the fiber, 10 base F. So fiber optic cable. So this is an expensive cable, most expensive cable it is considered, which is widely used. Okay, and these cables, fiber optic cables, these are mostly used in large buildings communication, large building network communication. So it is a highly expensive cable. Okay, so these are the 4 cables which are used for Ethernet. Now there is one task for you, all of you, that there is one meaning I have told you for this 10 base 5. What is the meaning of this base? That it, what is the meaning of 10 base 5? It uses 10 mbps. Then base is baseband signaling it uses, and it supports 500 range of 500. So the concept is what it is. It uses the baseband signaling. Okay, so there are two type of the signalings are used. One is the baseband that we have seen, and second one is the broadband. Okay, baseband and broadband. These are the two signalings are used, and some wires are used. Baseband we have seen. Now, what is your task is that you have to complete these two tasks. Okay, what is the difference in baseband and broadband transmission? That you have to search and tell me. What is the difference in baseband and broadband transmission? And second task is what? Which cables are used in broadband and which cables are used in baseband? So we have already seen here baseband मध्ये ह्या सगळ्या cables use होतात. So what you have to search which cables are used in the broadband transmission and what is the difference between these two. ठीक है? So that you have to find out now. Okay, this is the task for you. 2:30 is there. So again I'm having the next lecture. So in that lecture we will discuss this and we will go for the next point. Now how to complete? You have to take the paper, write the points and take the picture of that paper. Whenever I'll ask anyone, you have to show it to me. Don't send on mobile. I'm not going to entertain anyone personally. You have to show here and explain me. Okay, so this is the task for all of you, everyone. Have you understood what you have to do? Yes. What is the difference in baseband and broadband transmission? And listen that unless and until you understood what is baseband and what is broadband, you will not understood the difference. आणि फक्त दाखवायचं नाही, मी कोणाला विचारणार. You have to explain it. Okay, and second is which cables are used in both. ठीक है? So if the cables you will show me, so you have to explain these cables, huh? Because we have already seen. Okay, any doubt? Half an hour is there with you, so you can do easily. So after this lecture we'll meet at 3:15 again. In that lecture you have to explain me these 2 points and then we will go forward. Am I clear? Yes, am I clear? Am I clear? Yes. Aparna? Yes, ma'am. Have you got the question? Yes. Okay. ठीक आहे. काय डाऊट नाहीये सगळ्यांना. Okay, fine. So you can leave the meeting at 3:15. Again, we will meet with this task. Everyone done. पेपर वरती क्वेश्चन सगळे पॉइंट्स लिहायचे आणि समजून लिहा because I'm going to ask anyone and those who will not answer, they will means I'll not do anything. You decide what to do, but you have to give the answer. ठीक है? Okay, so you can left and complete the task and we will meet with the same link at 3:15.